Okay, we're going to review properties of quadratic functions. So let's recall properties of quadratic functions. Example 1, the simplest equation for a quadratic relationship is y equals x squared. Okay, so let's calculate the y coordinate and plot the quadratic relation. So I'll do a couple of these a little bit slower, and then if you need to go slow, you can go ahead on your paper. But if we have y equals, okay, we're given the x value, so let's start with -3. Okay, -3 squared. Okay, and when we sub in here, we bracket it, so we get 9. So the y value is 9. So we have -3, 9. Okay, y equals negative, or x equals -2. Let's go ahead and sub in the -2. So -2 squared, we get 4. So -2, 4. Okay, let's sub in the -1 and we get 1. Okay, and we go ahead all the way down this chart, 0 squared, 1 squared, 2 squared, and then 3 squared again. Okay, and when we go ahead and we graph these, our quadratic relation is going to look like this. Let's go a little slower. Okay, and you want to make sure that this doesn't look like a V, it's actually like a happy face. Okay, so it's a curve, it's not two lines. Okay, so finite differences. We touched on this in grade 9 with linear equations, and then we touched on it in grade 10 with quadratic equations. So example 1, for this equation here, y equals 2, x minus 3 squared plus 1, fill in the table of values and then calculate the first differences. Okay, so if you took this equation and you subbed in these x values, so let's say -3. Okay, we're going to go -3 minus 3, that's squared, and then plus 1. Okay, -3 minus 3 is -6, squared plus 1. We get 2 times 36 plus 1, and so that's 72, 73. Okay, and we're going to go all the way down this column, and we're going to do the same thing, but you can go ahead and you can fill this in on your calculator. You should have a calculator that will pre-populate so that you don't have to rewrite this every single time. You should just be able to overwrite it. Okay, so then we get 51, and then we get 33. So 51, I get 33. I'm going to override my calculator and put in a 0. I get 19, 9, 3, 19, 9, 3, and then I get 1. Okay, so that's the table of values. For the first differences, what we do is we go to the y column and we subtract up. Okay, and we always want to go up. So 1 minus 3, we get -2. Then we go 3 minus 9, and we get -6. 9 minus 19, and we get -10. And we go all the way up that column. So 19 minus 33, we get -14. 33 minus 51, we get -18. And then 51 minus 73, we get -22. Okay, so we can see that the first differences are not constant. Now the second difference is, we can shade this one in as well because it's going to be one less each time. We go up the first difference column, so this -2 minus -6, and then we put in the answer. So that's kind of -2 plus 6, so I get 4. Okay, -6 minus -10, I get 4. -10 minus -14, I get 4. And I get 4 all the way up. So what are the first differences constant? No. What does this mean? It's not linear. Okay, so it's not a line. So let's expand this a little bit and let's just make a note. Okay, let's go. The second differences are constant. Okay, and then what does this mean? It's quadratic. Okay, let's just go over an overview of properties of parabolas. So a quadratic relation is written in any of these three forms. Okay, as you can remember, standard form, which is y equals ax squared plus bx plus c. Okay, and then a can't be 0 because we actually need that x squared term. Okay, we can write it in vertex form, y equals a x minus h squared plus k. Okay, and we know from this one, hk is the vertex. Or we can write it in factored form, y equals a x minus r x minus s, and we know that the factors are r and s. Okay, just to point this out, the y-intercept is c in this case. Okay, so any equation that has any polynomial that has y equals x squared as their, like the 2 is the largest exponent. Okay, and then please note second differences are constant. Now, a parabola is in a U shape, so that's a happy face here or an unhappy face here. Okay, and they're symmetrical. There is a vertex in a parabola, okay, and this is where the parabola changes. So this parabola is going down, reaches the vertex, then goes up. Okay, or it goes up, reaches the vertex, and then goes down, for example. Okay. If it's a happy face, we say it opens up, and if it's a sad face, we say it opens down. We also call this vertex the optimal value. The optimal value is specifically the y-coordinate of the vertex. Now, there's an axis of symmetry. This is the line that divides a parabola into two equal parts. Okay, and that's where a parabola is symmetric about. So there's a line of symmetry, and as we know from linear equations in grade 9, vertical lines are in the form x equals h. Okay, so it's going to be x equals maybe 5, x equals 3, wherever this will occur. So this one would be 1, 2, 3. This would be x equals 3, and this would be -1, -2. Oh, and this would be x equals -3. And that would be the equation of like the vertical line, and then this would be the line of symmetry. Now there are three different types of solutions. We can either have a quadratic with no x-intercepts, which would be either above the x-axis and it opens up, or below the x-axis and it opens down. Okay, one x-intercept, which means that the vertex lies right on the x-axis, and that can again open up or down. Or we can have two x-intercepts, which is this scenario, and either the vertex is below the x-axis and it opens up, or above the x-axis and it opens down. Okay, so here are some examples. Example 3, given the shape of the quadratic relation, locate and state the values of the following. So what shape is this? Well, this is a parabola. Okay, where's the vertex? Let's go -1/2 and 6. The axis of symmetry is going to occur at that x value, so x equals -0.5. Okay, this opens down, so like a sad face, so direction of opening down, which means that the a value is negative. There's going to be a maximum because it opens down, so it's going to go up to a maximum and then back down, and the zeros are -3 and 2. Okay, so quite easy when we're actually looking at the graph. Now, what if we're given the equation? Okay, so let's go through these and do the easiest ones, okay? And then we'll actually calculate if we need to. So the shape of this, because it's something squared, like x squared, the shape of this is a parabola as well. We know that this is a quadratic. Okay, the vertex is -5, -3. Just remember that this h value, you always flip whatever sign you see here. The axis of symmetry is going to be that x value, so -5. Now, this here is the a value, 2, and that's positive. If it's positive, it means it opens up, giving us a minimum. Now, an overview of the transformation of quadratic relations, and this is going to come back because we're going to do the transformations of different functions this year. Okay, this equation here, so this is a vertex form, y equals a, x minus h squared plus k. This is the equation of the quadratic relation, y equals x squared, for all possible transformations. And we say all possible transformations because the a value is like the general for the stretch, and the h value is the general for the left-right movement, and the k value is general for the up-down movement. Okay, so let's actually go through this. So when we're talking about the a value, this is either going to be a vertical stretch by a factor of a, and this is when this number is greater than 1, or it can be compression, which is a fraction, and I don't want to say fraction as like say 5/3, because this is still greater than 1, this would still be a stretch, but I want to say like a decimal, so 0 decimal something. Okay, so less than 1, between 0 and 1. Now, the reflection would be the sign on it. So we talk about absolute value. The actual a value is just the number there. Now, if that number, if the a value has a negative sign in front of it, it opens down, positive sign, it opens up. Okay, so if a is less than 0, it's reflecting the x-axis. Okay, so h value, these are shifts left and right. And remember, in the vertex form of the equation, there's a built-in negative sign here, x minus h. So whatever h looks like, it's actually going to be the opposite, since there's that, again, built-in negative sign. So if h is greater than 0, so that is actually like it looks negative, then it's going to the right. And if it looks positive, it's actually negative, right? H is less than 0, and it's going to the left. Okay, you'll get lots of practice with this. So if it's not memorized, it will be soon. Okay, and then k shifts it up or down. If k is greater than 0, we're going up. If k is less than 0, we're going down. Okay, so the k we just listened to straightforward. Okay, transformations must be applied in the order of bed mass. Here's the thing. So stretches, compressions, and reflections, these are all multiplication. So those have, or like division. So those have to be applied first. Now, translations and shifts are addition and subtraction. Those have to be applied afterward. Okay, example 5. We're going to state in order the transformations that have been applied to the quadratic relation. Okay, and remember, y equals x squared is the base. So we have a 2 here. So this is a vertical stretch by a factor of 2. Okay, this one looks positive, right? So positive 6, but remember, this would have to have come from negative 6, right? Because there's that built-in negative sign. So this moves to the left, 6. Now the negative 5, that's straightforward, down 5. And that's it. Okay, next one. So we have this a value. So there's 2 parts to it. So this is a reflection. The negative sign is a reflection in the x-axis. Okay, the 1/2 is going to be vertical compression by a factor of 1/2. Okay, this looks negative, so it would have had to be positive -3. Or sorry, backwards here. Negative of positive 3. So this h value alone, remember this is the negative sign built into the equation. This will be, it's going to the right, 3, and this is going to be up 7. Okay, completing the square. So this is the last thing that we're going to cover in our review. This is the process of expressing a quadratic relation in like completely expanded or standard form. And this is like converting it to vertex form. It allows us to actually like identify what the vertex is, which is H and K. These two are going to be congruent, so they're going to be the exact same equation. They're just going to look a little bit differently. Okay, so I'm going to scroll down a little bit and we're going to follow these steps. I'll read through the steps on the first one, but then like the subsequent ones, I'm going to just explain it and you guys can follow along with the steps. Okay, so I'm going to do this hands-on. So example 6, we're going to write each quadratic relation. So it's given in standard form and we're going to write it in vertex form. Okay, so here are the steps. Number 1, we're going to group terms with x's in them. Okay, usually just the first 2 terms. And what we're going to do is we're going to factor out the coefficient of the x squared term. So this one's easy because the coefficient's 1. We can actually skip that step. Okay, so just know that the coefficient of x squared must be 1 to begin, so we can go ahead and begin. Now, complete the square by making the expression inside of the bracket a perfect square trinomial. Okay, that's our goal. So here are the steps of doing that. We're going to take the coefficient of the x term, which is -12. We're going to go to the side of our paper. We're going to divide it by 2 and square it. Okay, 12 divided by 2 is 6, squared is 36. Okay, so divide by 2 and then square it. What we're going to do is we're going to add and subtract that new term inside of the brackets. So essentially what we're doing is by putting in a plus 30, oh that's x, plus 36 minus 36, we're actually adding 0. So we're not changing our equation, but we're just changing the way it looks. Okay, step 3, remove the negative term by bringing it outside of the bracket. Okay, so if there was a coefficient in front of that we had like originally factored out, we would have had to like multiply it by the common factor, but there's nothing because our coefficient was 1. Okay, so let's just rewrite. So inside of our bracket, x squared minus 12x plus 36. Oops. Okay, and then outside of our bracket, -15 minus 36. Okay, so here are the last 2 steps. We can do these in one step if we'd like. Okay, factor the trinomial inside of the bracket. This is always going to be a perfect square, and if it's not, you did it wrong. Perfect square is going to be that it's going to be the same factor. So x minus 6 all squared, and then we have -15 minus 36, and we get -51. And that's step 5, is just simplifying that outside. Okay, so if we were asked for the actual vertex, it would be 6, comma, -51. Remember, this h, we flip the sign. Okay, and that's how we go from having any quadratic equation in expanded form into vertex form. Okay, so now, instead of going through all the steps one by one, I'm just going to explain them so I can embed them. Okay, so first of all, we bracket the 2 x terms. We have to factor out that 2. So y equals 2. So both those are going to divide by 2. We get x squared minus 4x. Okay, even if the a divided by like whatever number we have it doesn't yield a pretty number, you have to do it. The coefficient of x squared must be 1. Okay, so now we go to the side of our paper, we write our new x term, and we divide it by 2. So 4 divided by 2 is 2, and then we square it, which gives us 4. Okay, so inside of the bracket, we're going to add 0. So we're going to add 4 and subtract 4. And then 5 just comes down. Okay, we're going to let's rewrite it one more time. We have x squared minus 4x plus 4. We're actually going to take out this -4. Okay, so this is going to be a little bit different. Because the -4 is within this bracket, we must multiply it by that leading coefficient that we had factored out. So that -4 times 2. So we're going to have plus 5. We bring down, and now -4 times 2 is -8. Now we can simplify. So factor the trinomial inside the bracket, we get x minus 2 squared. And then what is 5 minus 8? We get -3. If we were asked for the vertex, it would be 2, comma, -3. Okay, this question is a little bit different. So it says determine the optimal value. So this actually wants like the y value, which is going to be our maximum or minimum, our y value of the vertex. So in HK, it would be our k. Okay, this one specifically says by completing the square. So if like an assignment or test says to specifically complete the square, you must show these steps. Okay, so I'm going to go fluidly through it. Coefficient here is 1, so we group the first two terms, and we don't have to factor anything out, so we can go straight to dividing 8 divided by 2, which is 4, and then squaring it, which is 16. So we're going to rewrite this, x squared plus 8x. We're going to add 16 and subtract 16. Okay, then bring down that positive 5. Now, when we take this negative 16 out of the bracket, we don't have to do anything because we didn't factor out a term initially. So what we're going to have is plus 5 minus 16. Okay, let's go ahead and factor this bracket. I get x plus 4 squared. And then what's 5 minus 16? I get negative 11. Okay, so this is going to open up because the leading coefficient here is 1, which is positive. So we have a min of negative 11. Okay, next one. Let's bracket the first two terms. We have to divide out this entire coefficient of x squared, so the negative 3. So we have y equals negative 3, x squared minus 2x, and then leave that plus 5 outside of the bracket. We only have to group the x squared and the x term. Okay, let's take that 2. We're going to divide it by 2 at the side of our paper, which is 1, and then square it, which is 1. So we're going to go x squared minus 2x. We're going to add 1, subtract 1 inside of the bracket. When we pull out the negative 1, we're going to multiply it by that coefficient, which is negative 3. So let's just rewrite. Y equals negative 3, x squared minus 2x plus 1. Okay, and we have, bring down that positive 5, and we have negative 1 times negative 3, which is positive 3. Now we factor the trinomial and add the end. So we have x minus 1 all squared, and then we have plus 8. So leading coefficient here is negative. This opens down. So we're going to have a maximum here of 8.